So today we're going to learn about ratios. In some respects, this is going to be some review because you worked a lot with ratios when you were in sixth grade. So our goal today is we're going to write and simplify ratios, and we're going to use proportions to solve problems. Our three vocabulary words that we're going to focus on are ratio, proportion, and cross products. We're also going to talk briefly about something called the mean and the extremes, but these three vocabulary are the focus. So we talk about ratios whenever we talk about comparing numbers by division. And it doesn't only have to be numbers, it could be things that represent numbers like variables. So I might talk about the fraction 2/3. 2 to 3 is the ratio. But I also might talk about the ratio of x to 5 or the ratio of A to B. And so A and B and X are all representing numbers in this situation. So they are still ratios, but we're using variables to represent them. Now let me go back and talk about the ratio 2 to 3. Many times a fraction is sufficient to represent a ratio, and we use that a lot. But I'm sure you've also seen us write things like 2:3. This means the exact same thing, the ratio of 2 of one thing to 3 of another. And we can even expand on that. We could increase the number of things we're comparing to something like 2 to 3 to 1. In this case, we probably would not use a fraction because there really isn't we have a numerator and a denominator. There really isn't room for a third item. So then we revert to this colon representation. And where might I use something like this? Let's say I'm cooking and I have 1 cup of rice, and I'm going to put 3 cups of water in, and maybe 2 cups of vegetables. So this would be the ratio that I would have my ingredients in. So we can use many things. There's no limit to the number of things I could have in a ratio. Real important to remember that if you have a fraction, the denominator of a fraction cannot be 0. So you can never have something like this of that you'd have 5 to 0 things. That's not allowed because you cannot divide by 0. A quick example of ratios that you've been using since Algebra 1 is for slope. So the slope we define as the ratio of the rise to run. That's the first definition we gave it. The change in y over the change in x. We also could calculate it, with m as y2 minus y1 over x2 minus x1. So any of these ways we could calculate slope would be perfectly okay to come up with the ratio. I'm going to focus right now on this representation. So I'm going to use the change in y over the change in x. So y is the vertical change, and x is my horizontal change. And so I can see that as I go on this line that I'm moving because we read left to right. This line is going down. It has a negative slope. What's happening is the y is going down, and the y changes from 3 to -2. So it goes down 3 units, and then it goes down 2 more. That's a change of -5. So this slope I would represent as the change in y is going to be -5. And now I have to find the change in x. And if we look at this, the x value, it's at -1, and it's moving to 2. So -1, it's gonna move 1 unit to 0, and then 2 more. So that's a change of 3 units. So this would be -5 over 3, and that would be my answer. That's the ratio that it describes the slope of that line. So here we have a picture of a rectangle, and we're going to illustrate, how we might use more than one number to compare using a ratio. And here we can see this width of this rectangle is 3, and then 7. So we go 3 to 7, and then to 3, the other side of the rectangle, and 7 again. Now that's probably more information than you need on that rectangle because some of the information obviously is duplicate. But here we're comparing 4 things using a ratio. In this example, the ratio of the side lengths of a triangle is 4 to 7 to 5, and they also tell us what the perimeter is. And they want us to find the length of the shortest side. Now, when you have a ratio, it is oftentimes a reduced ratio. So for example, in this, if I look at this particular ratio, it is possible that the lengths of the sides of this triangle are 40, 70, and 50. But it's good practice to reduce ratios to lowest terms. And so if we divide each of those by 10, we get 4 to 7 to 5. And notice that each number is multiplied or divided by the same value in the ratio. So when I tell you the ratio is 4 to 7 to 5, it really doesn't tell me the values that of the actual side lengths. I just know they're in that proportion. What I do know, however, is that whatever number I multiply that ratio by, it's going to be the same for all three parts. So I know that if I say I'm going to multiply by x, if I have 4x, that's going to represent one side, 7x is going to represent another side, and 5x is going to represent the third side of the triangle. And because I know the perimeter, I can figure out what x is. So this extra information about the perimeter is real important, because I know that if I add up all three sides of the triangle, it's going to equal 96. And so that's how I can find out what the actual side lengths are. And maybe they are 40, 70, and 50, but let's see. So I set up this equation. I have 7 and 5 is 12 plus 4, that's 16x equals 96, and then I'm going to divide by 16 on each side, and then I should get x. And 96 divided by 16 is 6. So I can see that my side lengths are not 40, 70, and 50. I'm going to take 6 times 4. My side lengths are going to be 24, and it's in centimeters. So I have sides of 24 centimeters. 7 times 6, I have one that's 42 centimeters, and 6 times 5, I have 30 centimeters. The actual question said, what was the shortest side? Well, I can see that my shortest side was 24 centimeters. So that would be my answer. So this technique is really powerful, and you're going to use it many times when you solve problems like this. So they're going to give you a ratio, and we're going to pick some variable to use as that multiplier. We don't know what that number is, so we're using a variable. And so then you're going to write 4x, 7x, 5x, or whatever the ratio is, and do some kind of calculation. So a proportion is defined as when we set two ratios equal to each other. And so you can think of it as two fractions equal to each other if the ratios are expressed in fractions. But again, fractions are not the only way we can express a ratio. And when we're talking about this, there are two new words that I want you to be aware of. And they're not words that I've used a lot in this context, so just be aware that they're there. And the two words are extremes and means. And you can see where this word extremes comes from, not so much when it's written as fractions, but if I rewrite this expression as using that colon notation, A to B, and then we'll say equals C to D. The extremes are the two values that are farthest apart. So we can see A and D are farthest apart. That kind of goes with the meaning of extreme, something that's way out there. And so A and D are the two that are farthest from each other. They're the extremes. And the B and C are called means because they're in the middle. And so these are the means, B and C, and A and D are the extremes. So in previous classes, you learned about the cross products property. And that property just says that if I have a proportion, so let's say that we had 2 to 3 equals x to 5. And I wanted to solve that for x, I could use cross products. So I would multiply like this. I would say 5 times 2 is 10, 3 times x is 3x, and then I'm going to divide by 3, and x is going to be 10 divided by 3, which would be 3.3 repeating. Okay? So we can solve problems like that. So here's an example, and let's use the cross products property to solve it. So I'm going to take and multiply 7 and 12, and that is going to be equal to the product of 56 and x. So we have 7 times 72. Doesn't matter which side I have the equal sign I put it on. I'm putting it on the left, but I could also do it on the other side. The important thing is which two of the values go together. So I have 56x equals 72 times 7. And so I'm going to multiply that out. I'm going to multiply 7 times 72, and then I'm going to divide that by 56. And you can just do that on your calculator, but another way to do it if you're not using your calculator is to just simplify like this. And so I have x is going to be equal to 7 times 72 divided by 56, and I can start reducing this fraction a little bit. I can look for common factors. So into 72, I know that 8 goes into 72, that's 9 times, and 8 goes into 56 7 times. And then I can see that there's a 7 in the numerator, 7 in the denominator, and so that's going to cancel out, and my answer is going to be x equals 9. That's all that's left. That's the same answer I would get if I did 7 times 72 and then divided by 56. So I'm going to write this with x on the left because that's usually the way you write it. So x equals 9. That is my answer. Of course, we're not in sixth grade anymore, so our expressions, our ratios are going to get a little more complicated when we solve these proportions. Here I have a proportion that has variables in both, one in the numerator, one in the denominator of z. And so we're still going to use that cross product to solve this. And so I'm going to multiply z minus 4 times z minus 4. And then I'm also going to have 5 times 20, which is 100. Now, notice that when you multiply something by itself, that's the idea of squaring something. So I'm going to rewrite this as z minus 4 squared equals 100. And we can take the square root to undo this idea that we're squaring something. So the next step is that I'm going to, and I'll rewrite this step. You wouldn't have to. You could just add to the piece you're on, but I'll rewrite this. Z minus 4 squared equals 100, and I'm going to take and do the square root of that. What the square root does is it undoes the square operation. And so now, if I take the square root of x squared, I get x. If I take the square root of z minus 4 squared, I get z minus 4. And so now I have z minus 4 equals 10, but not just 10. Remember that when you're taking a square root of a squared quantity, you get two answers. You get a positive answer and a negative answer. So it's real important to indicate that when you take the square root and there's a variable inside the square root, like here we have z squared, x z minus 4 squared, that the answer z minus 4 is going to give you both a positive answer and a negative answer. So you'll have to make sure that you write plus or minus 10. So there would be two answers to the square root of 100. There could be positive 10 or negative 10. So make sure in your notes that you have this example. So now I have z minus 4 could be positive 10, but z minus 4 could also be negative 10. So we're going to get two answers here. So I'll add 4 to both sides on the top one, and we have z is 14. That's one possibility. The other possibility, if I add 4 to both sides of the other one, is that I have negative 10 plus 4. So then z would be negative 6. And so these are the two answers for this this problem. Both answers would work. Now, if we know that z is a length, we could obviously get rid of the negative answer, because if we knew that z was an actual length, it would have to be positive. But we have no information about what z represents, so both of these are correct answers. In this example, they give us two quantities are equal with two variables that are different, And so we want to find the ratio of D to C in simplest form. So when it says the ratio of D to C, I think the easiest way to think about this is you want to get an answer where D over C in a fraction. So D is going to be on the top, and you want D divided by C. So we're going to start with 18C equals 24D, and I need to divide by C because I want C to be in the bottom underneath D. And you can see by dividing by C that I'm going to have D in the top, C in the bottom, the ratio of D to C. The other thing I need is I don't want any other numbers by this D over C. So I have D over C. I want to get rid of that 24. So at the very same time, I'm going to divide by 24. So 24 is going to go in the bottom of both fractions. And now I can see that the 24s will divide out as 1. And I also have the C's will divide out as 1. And so what I have now is I have 18 over 24 equals D over C. And that's exactly what I wanted. However, 18 over 24 is not in reduced form. So we do want to reduce it. So how can we reduce that? Well, what's the largest number that I can think of that goes into 18 and 24? And I think that's 6. So 6 goes into 18 3 times, and 6 goes into 24 4 times. And so my answer is the ratio of D to C is going to be 3 to 4. So here we have a problem about a girl, Marta, and she's making a scale drawing of her bedroom. So remember, scale drawing means it's not to the same size, but it's going to be in proportion. So, of course, she's not going to make a drawing that's life size of her bedroom. She's going to have it on a piece of paper, and it's going to be in the same proportions as her room. Her rectangular room is 12 feet wide and 15 feet long. So let's sketch a rectangle. So it's longer than it is wide. So we have a rectangle here. It's 15 feet long and 12 feet wide. On the scale drawing, and remember the units here are feet, but many times when you're doing these problems, the units are going to cancel out. So even though in her drawing it's going to be smaller, so here's her rectangle on her drawing, and it says the width of her room on the drawing is 5 inches. It's okay that in this case that the actual values are in feet, and the scales is in inches because the inches will cancel out with inches, and the feet will cancel out with feet. And so we want to know. The question is, what's the length of her room? So we want to know what this length is. And so we're going to set this up, and we're going to match up the corresponding pieces. So I can see that this is the width of the actual room. Here's the width of Marta's drawing. So 5 is going to go with 12, and 15 is going to go with X. So it's important that you set it up correctly, and that if I start with the larger room, 12, I'm going to go, Marta's drawing is 5. And that's going to be equal to, I have to start with the larger room again, 15, and then on the bottom I'm going to have the X. And so this would be the problem that I need to solve. So I will use my cross product principle, and I will have 12x is going to be 15 times 5, that's 75. And now I'm going to divide by 12. And so x is going to be 75 divided by 12. And my units are going to be in inches. So if I divide that out, I get x is 6.25. So on her drawing, the length is going to be 6.25 inches. And that's the answer.